Good morning, sir. We are Group 5. Now we are going to present our project A, DC power supply. Our project title we chose was number 9, DC power supply with a fixed 9 watts output using a brave rectifier. So let's us introduce our member first. I'm Cheng Louis, and
I'm Chong Wei.
And I'm BOOI.
Alright, so thank you, Luis. Our title is option number 9, DC power supply with a fixed 9 volt output using a bridge rectification. So to convert the AC to DC, it has 4 steps. The first, we use a transformer to step down the voltage. So the second is a rectification, which uses 4 diodes to convert the AC supply to DC. And the third is a filter. We use a capacitor, and this capacitor is used to smooth out the voltage. So during the rise of the voltage cycle, and the diode gets charged, and this charge will be supplied to the load during the fall in the voltage cycle. So the last one is a regulator. We use a ZHEN diode, which maintain a constant voltage to the output. For the output, we use a resistor to obtain the output voltage. So this is the PCB board of our circuit. Right, next I'll pass it to BOOI for the simulation.
Okay, thank you, Chong Wei. So now I'm going to simulate for the part A. Okay. So for the part A, we have few test points. So for the first test point is before step down, the voltage before the step down, and the second point is the voltage after step down, and then the next test point is at the voltage after rectifier, and then the voltage after the filter, and also the voltage after the voltage regulator circuit. So the first test point is the voltage before step down. So we simulate it, and then we test this point, and it shows the sinusoid. It shows a sine graph. Okay, so after being stepped down, by using the step down transformer, it shows the amplitude is being stepped down. Okay. Okay, so next, we need to select for the voltage after the being rectified by the bridge rectifier. So after being rectified, the AC is converted to pulsating DC. So it shows like this. So next, the next test point is at the filter circuit. So the filter circuit is used to smoothen the circuit. It's used to smoothen the DC circuit. It's used to smoothen the DC supply. So here is the point. Yeah, it shows like this. And then this is the transients part. And here is the DC supply being smoothened. And then finally, we need to use the voltage regulator circuit, which is the ZHEN regulator, to convert the smoothened DC to the constant DC. So we test this point, and then it shows our output is 9 volt, and it shows the 9 volt voltage. We can drag this cursor, and then it shows, yeah, it shows 9 volt, 9.31 volt. Okay. Okay, so that's all. Thank you.
good morning, sir. I'm Luis. Now I'm going to present the PCB project B. For me, I'm choosing the topic water level indicator. From this experiment, I'm using 5 LED. The white color LED is presents the 25% water level he would like, and the green color is present 50%, and the blue color is present 75%, and the yellow color is present 100%. Then when the water level is reached the danger level, the red colors will light out and the buzzer will ring. And also, I'm using 5 transistors in my experiment, and each of the base is linked to the cup to present a switch to the water level. Now I'm going to simulate the experiment. Okay. It's reached the 25%, and the white color is light, and I continue. The green color is light, the blue color is light, the yellow color is light, and finally the red color is light. The buzzer is ring, but it sounds small, but you can see the red LED is connected, so the buzzer is ring. Thank you.
My name is ZHEN. Today I'm going to present you with the level indicator. So now I'm going to pour some water into the container, and the LED will be light up accordingly based on the water level. The buzzer will be switched on at the end of the experiment.